All right, so what we're going to look at here is sensor testing on 2 and 3 wire sensors. We're going to talk a little bit about what you do with your multimeter to check and see if the sensor is working, how to interpret what you see when you're back probing the various different wires on these sensors, what you should expect to see, and what you will see if you have a problem. The types of problems that we're typically going to encounter with sensors, either a problem inside the sensor, a problem in the harness, or least likely a problem in the controller. Any of those faults, though, they usually generate different types of fault codes. And two of the most common fault codes that you're going to find would be an out-of-range high and an out-of-range low fault code. Out-of-range high fault codes. What that means is the ECM is looking at the signal wire coming back from the sensor, and it's seeing 5 volts. It shouldn't see 5 volts, but it is. The highest on a normally functioning sensor that you should typically see is about 4.5. Different manufacturers have slightly different numbers for that, but usually somewhere around 4.5 is the highest the signal voltage should ever get on a properly working circuit. If it goes to 5, that means there's something wrong. And this is how the computers nowadays, the controllers, are able to perform those self-diagnostic tests, and they're able to tell if there's something wrong and set a fault code. An out-of-range low fault code means we're seeing 0 volts instead of the 0.5 volt minimum that we would normally see on a properly working circuit. There is a standard that a lot of modern manufacturers adhere to. That's your SAE J1939. And that defines a lot of stuff in terms of electronics. But one of the things that it does define is certain numbers that are associated with certain problems. And you have things like MIDs, PIDs, FMIs, and what that's really talking about is your first portion of a proper, SAJ 1939 fault code. The first portion of it is talking about what system has the problem. Okay, so which address, which controller is experiencing this issue? Is it the engine controller? Is it a transmission, or is it hydraulics, or a body controller, something like that? So the first part of your fault code is going to tell you what system has the problem. The next part of the fault code is going to be, again, usually 3-digit number, but that's going to indicate which parameter is experiencing the fault. That's your PID. And then the final portion of the fault code is going to be the FMI. That's the fault mode identifier. And that tells you what kind of a problem we're having with that circuit. Is there an open? Is there a short? Is there, too much current, not enough current? Do we have our data coming back all garbled? There's a bunch of different FMIs that are associated with different types of faults. Okay, so the FMIs that are associated with sensor faults where we have out-of-range highs and out-of-range lows, those FMIs, it's a 2-digit number, okay? Be an 03 or an 04. And out-of-range high, or voltage out-of-range high, or voltage out-of-range low, 03 and 04. 05 and 06, those are current out-of-range low and then current out-of-range high. And those are, there's I think like 31 or 32 different possible FMIs out there. And you're going to see a lot more than just these couple that we're focusing on. But when we're talking about sensor testing and things like, broken wires or shorts or problems inside of a sensor, these 2 FMIs are typically the ones that you're going to end up with at the tail end of your fault code. We don't usually have to memorize this nowadays because most of our fault codes on our displays or on our electronic service tools, they've also got a fault code definition there for us that tells us what the problem is. All right. So when we're talking about sensor testing on 2 and 3 wire sensors, what we're going to do is we're going to take a look at each one of the wires on the sensor, your reference, your signal, your return. And if we have an FMI set, we're going to take a look at where the faults are in the circuit and what the voltages at various points in the circuit would read when that fault is present. So let's start with a 3-wire sensor. So if I have a 3-wire sensor, and I'm going to do this very simply as a potentiometer. A potentiometer is very easy to understand how it works. We're going to show that we have ground, we have our analog to digital converter inside the ECM, and we have a 5-volt reference inside the ECM. I'm going to show my harness connections. And then my harness connections are showing me what's in the, or what part of this circuit is ECM, harness, and sensor. Okay. So in this diagram here, my reference, my signal, and my return are these wires. What I want to do now is take a look at what could happen to this circuit to cause an out-of-range high fault code. An out-of-range high fault code means one thing. It means that the ECM is seeing 5 volts on the signal wire when it shouldn't be. So what could cause that? One of the things that could cause that is an open return. Another thing that could cause that is VREF to VS short. So this is the fault that I have. And if I take my multimeter and I hook my multimeter up to ground, and then I take the other end of my multimeter and I start back probing stuff. And when I'm doing initial troubleshooting on, excuse me, on a circuit, and that circuit's got some sort of a fault code set, I want to test a live circuit. I want to check the voltages on the live circuit and see what's happening with the circuit plugged in, with that sensor plugged in. And I know the computer thinks it's seeing 5 volts. I want to see where else I'm going to see that 5 volts too. Because the only thing the computer's telling me is that it's seeing 5 volts right there. The other end of my multimeter, I hook it up and I check my reference. Okay. On my reference, I'm going to have 5 volts. I take my multimeter and I hook it up to my signal, and I'm going to see 5 volts. And then I take my multimeter and I hook it up to my ground, and wouldn't you know it, I see 5 volts there too. What that's telling me, we'll just take that out of there. If I got 5, 5, and 5, that's telling me the return is open. Because I'm feeding 5 volts reference into this circuit, and that 5 volts has got nowhere to go back to ground. The analog to digital converter inside the ECM is fairly high resistance, so it's going to act like another open in the circuit. So all I got is 5 volts everywhere in the circuit. Okay. Now let's say that the problem was a shorted reference and signal wire. And this could easily be inside the sensor, or it could be in the harness. But if I've got a shorted signal wire and I take my multimeter and I put it over here, I end up with 5. If I take my multimeter and I put it over on the signal, again, I end up with 5. If I take my multimeter and I hook it up on the ground, I get 0. So 5, 5, 0. So at this point, I don't know if the short is in the sensor or if the short's in the harness. Now, one thing that you may have talked about previously is fault code state of change troubleshooting. If you're familiar with that, great. If not, this should be pretty helpful for you. So fault code state of change troubleshooting is where I know that I've got a fault code, an out of range high fault code, and I want to see if I can force that code low. And if I can, that tells me quite a bit about where the problem is in the circuit. So in this instance here, if I've got a short between my reference and my signal, if I unplug the sensor, the fault code is still going to be present because I'm still dumping 5 volts to the signal. If the problem is in the harness, that happens. If the problem is not the harness, but it's the sensor, as soon as I unplug the sensor, my fault code is going to change. It's going to go to an out of range low because now there's nothing else feeding back down the VS. And instead of seeing 5 volts there, the ECM now sees 0 volts. That's fault code state of change troubleshooting in a nutshell. Now let's say that the problem, it wasn't a short in these wires, it was an open in the return. When everything was plugged in, I had 5s across the board on all my wires. Okay. Well, as soon as I unplug the harness, all of those 5s, well, 2 of those 5s are going to go away. Okay, the sensor's not plugged in anymore. And that means I'm going to have 0 and 0 over here if I was just measuring the voltage. But as soon as I unplug the sensor, another thing happens. This goes to 0 as well. So again, that fault code state of change troubleshooting, if it goes away, you know that you've changed the state of the fault, and you know that the problem is quite likely in the sensor or the harness, depending on what your live voltages were with everything plugged in at first. Something you want to be aware of, anytime that you see 5s across the board on a sensor, usually that means that you've got an open ground. That's a pretty common thing. Let's take a look at what would cause out of range low. 3-wire sensor, out of range low. And just remember too, with both of these, the associated FMI, 03 and 04. So for an out of range low fault code, here a couple of different things could have happened. I might have an open VS, an open V reference, or reference, not reference. Yeah, reference, sorry. If I have an open in either one of those wires, I'm not going to be getting any signal back to the ECM on the signal wire. I might have an open sensor. So to figure out what the problem is here, and there's another thing that might be an issue, and that would be that I've lost my reference inside the ECM. That can happen. But it's more likely that it's a broken harness wire, or maybe a sensor that's failed. And to figure out which one it is, again, I'm going to get my multimeter out and I'm going to start measuring voltages at different places in the system. If the problem is an open reference wire, when I have everything plugged in and the circuit powered up, I got 0s across the board. That right there tells me I've got an open reference. Now, if I want to figure out if the reason that I've got 0 over here is because of an open in the harness, I'm not going to see 0. I'm going to see 5 when I check the ECM connector. I'm going to see 0s everywhere else at the ECM. Sometimes you're asked to do voltage drop tests. Okay, well, in this case here, a voltage drop test, if I had my voltmeter, would be something like this. And if I'm checking across that broken wire, I am going to see 5 volts. So if I have an open in my signal, this is one that can be very confusing if you're sort of inexperienced with things, because an open signal can actually look like everything's working right when you get your multimeter out and you start measuring at the sensor, because you have an intact reference. So that reference is going to give you 5 volts. The sensor itself hasn't failed, so if you do a sensor sweep, it's still going to generate a legitimate signal voltage. And you're also going to have 0 volts down there. So when you do your testing, you got an out of range low code showing on your, let's say, service advisor or whatever it is you're using. Now, everything at the sensor looks great. The computer's not seeing it. The reason is an open signal. Okay. Now, another possibility is that the open is somewhere inside the sensor. And if the open is somewhere inside the sensor, you're still going to see your half, or sorry, your 5, your 0, and your 0 over here. So what you need to do is think about how the circuit works. Check your voltages with everything plugged in and powered up and just see what's happening first of all. And then try and force the fault the other way. If I have an out of range low fault code and I unplug the sensor, nothing is going to change. All right, even on a properly working circuit, well, assuming a properly working circuit, if I unplug the sensor, then I do create an out of range low. So unplugging the sensor doesn't do anything. What you need to do is jump reference and signal together. If I had open reference wire, I would have had zeros. I would have known that anyways. But if I had an open reference or an open sensor, I may not know that, but I can very easily confirm that the harness is good by jumping those 2 wires together. If I do that, I should create an out of range high. If I got an intermittent fault, and that intermittent fault is being a little bit difficult to find, then I'll create an out of range high intentionally, and that'll start doing a wiggle test down the harness. And I'm going to watch the output. I'm going to have my parameters showing on my service software. I might even be graphing it. And then I'm going to walk along and start wiggling harness connectors and wires and look and see if we see a dropout in that graphing on that parameter. So the next thing that we're going to look at here is going to be a 2-wire sensor. So if I got a 2-wire sensor, I've got something that looks like this. And we're just going to, keep this simple. We got a variable resistor over there. Okay, that variable resistor is hooked up to the ECM. And inside the ECM, we have a reference. So this is a 2-wire temperature sensor. That's the example that we're using here. Our harness connections that show us what is the ECM and what is the harness and what's the sensor. We'll put those in there. And now we can see that our top wire is our signal and our bottom wire is our return. When everything's working normally, you feed 5 volts into the circuit. Depending on what the resistance of that variable resistor is, that's going to dictate how much of that 5 volts we dump off to ground and how much of it we're sensing as a signal. The higher the resistance, the higher the signal voltage. The lower the resistance, the lower the signal voltage. And when I'm talking about the resistance, I'm talking about the resistance of the sensor itself, because that variable resistor, that's the thermistor that makes up that temp sensor. So in this example here, an out of range low, or sorry, out of range, let's start with out of range high for an FMI 03. What could cause an out of range high on this? An open return, or an open signal, or an open sensor? It could be any one of those three things. So once again, I've got my trusty multimeter and my back probes out, and I'm just checking to see what the voltages are at various places. First thing I always do is I've got the circuit powered up, and I check the voltages at the sensor connector. And if I have an open return, I'm going to end up with 5 volts on both of the wires at the sensor, because the open return, we don't have any path back to ground. Okay. If I have an open return, can I force this code the other way? Fault code, state of change, troubleshooting. Can I force it the other way by unplugging it? No, that's not going to do anything. What I can do though is I can figure out if my harness is good with a simple test. I can unplug the harness from the sensor, and I can jump those two together. And that gives a direct path back to ground without the resistor in the way. And my out of range high should have changed to an out of range low code on my software now. That's a quick test to figure out if your harness is any good if you got a 2-wire temp sensor like this. So if I have an open in the signal wire, if that's my problem, I should have had, I have an out of range high. So I would have expected to find 5 volts at the sensor, but what I actually found was 0 volts on both because I have an open signal wire. Now, if I want to figure out where that open in the signal wire is, I'm going to come back to the ECM and I'm going to measure and see that I've got 5 volts there. If I don't have 5 volts coming out of the ECM, that's telling me I don't have any reference voltage in the ECM. If I have an open in the sensor, once again, unplugging the sensor isn't going to change the fault code. But one way that I can confirm that the harness is good is by jumping the signal and the return together, and that should flip my code from an out of range high to an out of range low. Okay? So knowing all of that, an out of range low fault code, what could cause that? Well, a shorted reference, or sorry, a shorted signal to return, or a shorted sensor. Those are pretty much the two things. And the other highly unlikely thing that could cause an out of range low is a failed reference internally in the ECM. Okay, not impossible, but the least likely thing. When I've got an out of range low fault code, everything's plugged in and powered up, and I check my voltages at the sensor, I've got 0 volts. Okay, I do know that if the short is caused, or sorry, if that out of range low is caused by a short in the sensor, I know that if I unplug the sensor, now I've removed a path to ground on the signal, and that should go high. So fault code state of change troubleshooting in this scenario, just simply unplugging it should cause the fault to flip-flop. If the problem is, so let me get that out of there. If the problem's in the harness, you had an out of range low, problems in the harness, you unplug, nothing's going to change. Then you need to start searching for a short to ground in the harness on the signal wire. Okay. So what we've covered here is basically looking at 2 and 3 wire sensors Your 2-wire sensor in this example here was a thermistor style with an internal reference voltage on the ECM. The 3-wire sensor could be any 3-wire sensor, providing it's got an analog 1/2 to 4.5 going back to the ECM. The out of range high and low fault codes, we've taken a look at identifying what the voltages should be at the sensor end. And if you're doing this type of troubleshooting in the shop, something you may want to do is get used to these little diagrams that we've drawn. Go ahead and sketch one out quick on a piece of paper and go ahead and write down the voltages that you've got in different at the different connectors on the circuit there at the ECM and also at the sensor side. And when you start writing down those voltages, all of a sudden it's just staring right at you what the problem is. Okay. So I'm going to do one last thing here before we shut her down. I'm just going to write down some numbers, and based on those numbers, we're going to be able to see exactly where the problem is. I got my multimeter out, I'm back probing, and I see that I've got 5, 5, 5, 0, 5, 5. Okay, so just by doing this testing here, right away I can tell I've got an open in the return. Just writing the numbers down. It shows up right there. So if you're not super familiar with this type of troubleshooting, get used to just sketching out a simple circuit, write the numbers down, and then you can find the problem.